Hello, this is Phil Parker, and right now I'm going to start our discussion about data reduction with a video that introduces the economic fundamentals of the subject. Basically, we're going to do 3 videos on this. The first one is the theory behind data reduction as seen by business leaders and executives. Then the second video is going to give us a little bit more details of the different types of data reduction technologies. For example, factor analysis versus multidimensional scaling. And then the third one, we're going to visit a couple of widgets and play around and just demonstrate some of these different techniques. All right, so let's start with the economic rationale. The way I like introducing this to people is simply talking to them about hoteling beach problems. Now, Harold Hotelling in 1929 kind of invented an entire field, what we refer to as spatial economics. These were little puzzles, if you would, that would talk about competitors in a marketplace. These puzzles were so complex to solve, but easy to understand, that almost an entire field of mathematics had to be invented, and that field is called game theory. Von Neumann and Morgenstern, an Austrian and Hungarian duo, kind of invented this mathematical approach to solving these spatial competition problems, which turn out to be data reduction problems. Later, other people won Nobel Prizes based on their research in this area. So let's start with a hoteling puzzle. For those of you who might remember that name, there's something called the hoteling t-statistic, a generalization of the student's t-statistic that you often use in regression analysis to evaluate the statistical significance of a coefficient. Okay, so here we go. Imagine you've got a beach, a 300-meter beach, long beach in the south of France. So the month of July, wall-to-wall German and Russian tourists. They're everywhere, like walruses on the beach. They get up from their hotels, eat their breakfast, cross the street, boom, laying blanket to blanket across the beach. Okay, question. Is there an unfulfilled need on this beach with all these hot, sweaty tourists? Well, an entrepreneur is going to go to the local mayor and say, Mayor, can I have a license to sell ice cream to these hot, sweaty tourists? Seems like they'd like some ice cream. And the mayor thinks about it and goes, you know, this is an interesting idea. Sure, I'll give you a license. But listen, I don't want you walking up and down the beach bothering the tourists. I want you to locate your ice cream stand right here at point A. Now, point A is where it has to be and poured in concrete. And by the way, your ice cream you're about to sell, I want you to supply it for my cousin, Francois, who is going to give you vanilla, chocolate, and strawberry. So, the first ice cream stand opens up on this beach in Saint-Tropez, and some Germans are eating the ice cream. This is wonderful, but some of them are not. The tourists at the far end of the beach are not visiting the ice cream stand because, you know, it's not fun walking over hot, sweaty Germans. Okay, fair enough. So a second entrepreneur notices that there's still some unfulfilled need in the marketplace. There's a spatial gap in the market. Goes to the mayor's office and says, hey, mayor, you know, there's a lot of unsatisfied tourists nowadays because the current incumbent, the monopolist incumbent, really isn't serving the needs of the customers. I would like to have a license to compete on this beach as well. The mayor thinks about it and heard about these complaints and said, sure, that makes sense to me. I'm going to grant you a license. But then the entrepreneur stops the conversation and says, hold on, Mayor. Listen, if you start giving away licenses to all these different people, and we have 3, 4, 5 entrants, none of us are going to make money and we'll all go bankrupt. So I'm willing to sell ice cream on the beach if and only if you guarantee there'll never be another competitor on the beach. Now we have the first incumbent at A. Okay, fair enough. The mayor thinks about it and says, you know, I understand your problem. You have to make a profit. So, okay, I'll give you a license to compete on the beach, and there'll only be 2 companies, setting up a duopoly. Now, a regulator might want to have a duopoly because at least you'll get duopolistic competition. So, the mayor says, granted, I'm going to give you a license, and there'll never be a third entrant ever. However, I'm going to regulate you a little bit. Number 1, you're not allowed to have a mobile ice cream stand. You have to pour your ice cream stand in concrete, just like A. Number 2, you have to be along this center dotted line along the beach. Someplace along that dotted line, you're not allowed to put your ice cream stand on top of A and bury them in concrete. That's a mafia move. Let's make this clean competition. Anywhere on that line except for on A. Third, I want you to make sure you supply the same quality ice cream as A from my cousin Francois, vanilla, chocolate, and strawberry. Little corruption going on. Perfect. Now the second entrant opens up their stand. Question: where should they locate? This question is very realistic. There's an incumbent in an area. You need to locate your ice cream stand. Question: where do you locate them? Now, I will take a room of 30 executives and I'll ask them this question. And they will debate with their neighbors on a number of different locations. And let me map a few out right here. We've got B1 adjacent to A. B2 kind of in the center. B3 kind of symmetric on the other side. B4 in between that symmetric answer in the middle. And then B5 between A in the middle, let's say. That's typical. We get that variation of answers, correct? All right. And then I ask people to vote. It's their money. Where would you put your ice cream stand? So out of a group of 30 people, about 15 to 20 might put it on B1. Another 5 to 10 might put it on B2. Another 2 or 3 B3, maybe one person B4 and one person B5. You get a distribution like that. And typically what I say is whenever you ask a group of smart people, and you guys are smart people, the same question, and you get variances of answers like that, you know what that smells like to me? Consulting revenues. So let's start with the one that got the most votes. That's B1. And then I'll simply draw a line and say, well, it looks like that if you located B1, people walking down the beach will go to B1 and buy their ice cream. We get 80% share and A gets 20% share. Now, according to hoteling, now that was a long time ago, but the theory was that this was the absolute worst place to locate. This was the profit minimizing solution. You're totally fired. The company's gone bankrupt. You are dangerous if you voted for B1. Why is that? If you locate next to A, is A happy or is A pissed? A is pissed. So what is A going to do? A is going to drop its price just enough to incentivize customers to walk one extra meter. Once they walk that one extra meter, how much share do you have? You have none. They have 100%. A has 100% share. So what do? You drop your price. In essence, by positioning yourself near the competitors, you've in essence started a price war. In the world of business, this is called commoditization. Zero profit. This is bad. Now, I'm not sure what you remember from your economics class about competition. Is competition good or bad? Most people say competition's good. No, it's a disaster, especially for shareholders. You do not want a competitive solution. You want the opposite of that. You do not want competition. That drives profits down. So there's an alternative to that solution. You simply go to B3, to the opposite side of the beach. You go to the opposite side of the beach, and what do you have? You get a buy monopoly. You get a buy monopoly. Some people might call it tacit collusion. Others, regulators, might call it market splitting. Basically, you've avoided competition. Actually, you've also increased the demand for ice cream. More people are buying ice cream. Now, why is it that we have less price competition? Because we've maximized the switching cost on the part of the consumer. Imagine you have the typical German tourist Hans sitting in the middle of the beach in Saint-Tropez, right? Sitting in the middle of the beach and then says, I want the cheapest ice cream. So what do? They walk over to the ice cream stand at B3. I wonder if that's cheapest. I don't know. Let's walk over to A. Walks over to A. Oh my gosh, it was cheaper. Walks back to B3 and then sits down. Will Hans do that? No, Hans won't do that. You can easily see this in the real world by asking people, how many of you tend to go to the same grocery store every single week? To the same grocery store every weekend, always the same place. You tend to go to the same place. That's a local monopoly. You go to the closest one. So by locating on the opposite side of the beach, we have reduced competition and increased profits for B. Now, that solution has a word in marketing where you locate far enough from your competitor where you do not create price wars. That's called differentiation. Differentiation is the antithesis of commoditization. And that's what marketers are paid for, is to come up with ideas that make you look different than competitors. Okay, so we've maximized switching costs. Now, if ever you want to solve a strategic planning problem in business, it's a two-step solution. Step number one, find the cartel solution first. Then, if you think you can improve upon it, do so. If you cannot improve upon the cartel solution, then don't. Now let's look at location B1. B1 was a testosterone move. All of these aggressive managers who want to be competitive, let's screw A. In reality, the optimization problem would lead to not screwing A. You screw A, they screw you back, and nobody makes any money. So, you start with the simple two-step approach. Step one, find the cartel solution first. Now, what would that be? A cartel would own both ice cream stands, right? So, if a cartel owns both ice cream stands, we have one at A. Where would we put our second ice cream stand? Well, the answer is probably on the other side of the beach at B3. That's probably what a cartel would do. So that's step one, find the cartel solution. The second part is, can I improve upon that? And if the answer is yes, then go ahead and do it. And this is where a lot of fancy mathematics comes in and game theory, because it depends on many things how much closer you go to A. And let me just say one consideration might be how hot the sand is. If the sand is extremely hot, you could probably move 1 extra meter over towards A and not start a price war. Maybe you can move 2 meters over, again, if the sand is hot enough, and still not start a price war. So where would you ultimately locate? Maybe someplace around B4. Compete, but not too much. All right. So that's an introduction to the hoteling puzzle and spatial competition. We'll relate this to data reduction a little bit later. Given the variance of answers on that first puzzle, let me now give you a second puzzle. The second puzzle is a price speech. You ask a group of 30 people, when did you first buy your first iPad? And you say, who bought it in 2010 when it first came out? And you'll get 2 or 3 people to raise their hands. Let's call those the innovators, the beginning of the life cycle curve. Then I'll say, who bought it, let's say in 2011, 2012 maybe. You get 4 or 5 people. How about from 2013 to 2014? You get more people. Eventually you say 2016, a lot of people raise their hands. And then you say after that, 2017, a little less people raise their hands. 2008, 2009, 2020, only 1 person. And then I say, who has never bought an iPad before? And there'll be 4 or 5 people that'll raise their hands. Those I call the hermits. They're isolated from the social network. They're not being influenced by others. The early adopters, those 2 or 3 people who adopted, the innovators, they influence the next segment, the early adopters, etc. This is classic diffusion theory that was developed in the 1960s at Stanford University by Everett Rogers and others. So this bell curve or life cycle curve is nothing more than a footprint of the diffusion process across segments. Okay, now if we look at this from an economics point of view, that's basically the equivalent of a demand curve. A very high price, very few people will purchase the product. At a low price, more people buy the product. Many consumer electronics products, the prices fall over time and more people will eventually adopt the product. Let's represent that as a pear-shaped beach. A pear-shaped beach, which we'll call the price speech. 2 companies are selling exactly the same product. They are literally both iPads, identical. There's no different. They have the same brand name, same technology, same box, literally identical. The only thing that these firms can choose is their prices. The first entrant, let's call that A, is located kind of at the top of that pear-shaped beach. You see, at the top of the pear shape, there's very few customers. That's the top of the demand curve. There's very few people willing to pay that higher price. As you drop price, we end up getting a mass market effect where a lot of people are willing to pay for that product. In the world of economics, we might say that's where the elasticity equals -1. It's where the bulk of the market might be. Okay, now you're the second entrant. A is only selling to the innovators. Where do you put your price? Very realistic question. Where do you position your price? If you price it above A, nobody will buy your product because the two products are identical. They're both iPads, right? So you cannot price above A. Where do you put your price? You ask a group of 30 people, and here's what happens. People will say, how about right below A? Just a little bit below A. Some people will say right there at the middle of the mass market. Some people will say between that mass market and right below A. Some people will literally say, let's price it at the bottom. The bottom is defined as marginal cost. That's where you price at marginal cost. We have a word for that in business. It's called communism. There's no return to the investors if you price at marginal cost. But we can put that down there nevertheless. Between that communism and the mass market, you can call that socialism if you like. Okay, now you have to decide where to price. You ask 30 people, where do you want to put your price? And you end up getting a variance of answers. There'll be a lot of people who will say just below A. Some people will say right at the mass market. Some people will say else, etc. Well, whenever you ask a group of smart people the same question and you get variances of answers, what does that smell like to you guys? Yes, indeed, consulting revenues. Okay, according to Harold Hotelling, anything below A is profit minimizing. Even a little bit below A. Is A happy or is A pissed? No, A is pissed. So what will A do? Now remember, this is the price beach. So what will A do? A will retaliate and fight back. What will you do? Suffer. So what will you do to A? Fight back. Boom, boom, boom. You will compete with each other all the way to the bottom. Competition leads to communism. This is literally the result of a hoteling game. There is one solution to this game. Find the cartel solution first. What does that mean? You position at the top of the beach next to A and split that market. After the innovators have been sold to, there's no more market to serve. Both companies will then go down the beach. Now, a journalist will see prices falling as these two competitors who mimic each other fall down the beach and price better and better to the customers. And they might say it's due to competition, when in fact, it might be just a very clever way of doing what we call in economics temporal price discrimination, charging a high price to those willing to pay a high price and lower prices thereafter. Okay, a little bit worried in typical cases here because most people had never got the first solution nor the second solution. Let's go to the third solution, the third puzzle rather. And that is one that's largely motivated by the research of Margaret Slade, brilliant economist at the University of British Columbia, Vancouver. She came up with this simple puzzle, and she empirically was testing this in many of her papers. Absolutely brilliant research. Basically, you've got an intersection, and the traffic is going in both directions at about the same density, about the same traffic patterns. And let's assume that 90% of the people do not turn right and do not turn left. They just don't. Most people go through 10 intersections before actually making a decision to make a turn left or right. There's an incumbent in the market on one of the corners. Let's call that A. So there's a gas station located at A. You are asked to open up a competitive gas station. You really only have a few choices. You could locate at B1, you could locate at B2, or you could locate at B1. You'll notice that B1 is labeled the same at both corners of the intersection. Why is that? Because mathematically, it's kind of the same thing. It's locating in the same density pattern. So the question is, where do you locate? Are you going to locate in B1 or B2? That's the only choice you've got. There's never going to be another competitor. Don't worry about that. Just where would you locate it? Now, good news, out of 30 people, about 28 people will say B2, which is the correct answer. It's kind of the cost of the left-hand turn. In order to drive through that intersection, remember, 90% want to go past that intersection and continue forward. To turn left, go to the gas station, then pull back out, and then drive on out again. Oh my gosh, that's a huge transaction cost. The cost of switching is very high. So in essence, by increasing that cost of switching, you're tending to get higher profitability when gas stations are located at, cata corners of each other at an intersection. In the same vein, if you have a gas station at the edge of a town, do you put it on the outbound lane where the next gas station is maybe 10 to 15 miles away, or do you put the gas station on the inbound lane? The answer, of course, is on the outbound lane because the next competitor is farther from you. So, in the field of economics, we use spatial economic theory to understand the structures of competition. If people are clustered near each other, different restaurants, then chances are they're not really competing. They might be complements to each other, like a food court. One will be Italian cuisine, one will be Mexican cuisine, one will be American fast food, all in a food court. They're complements to each other. And those restaurants would be far from each other in terms of substitutes, typically. If you do find restaurants of the same type near each other, probably their profit margins will be lower than those that are spaced farther from each other, etc. So we spend a lot of time doing GIS, Geographic Information Systems. There's a number of databases available for one to do these analyses. OpenStreetMaps, for example, is a free resource you can download to do geospatial analysis of competition in a market. Now, the question becomes, how in the world does this relate to data reduction? Well, it's very simple. Imagine a consumer is looking at two products. Maybe it's pocket calculators. Now, calculators are complicated, right? There's thousands and thousands of technical dimensions, details in simple calculator. But when a consumer walks up and compares two calculators, how many of those technical dimensions are they psychologically really using? If I'm going to have artificial intelligence and train a model to think the way humans think, well, how do humans actually think? How do they make a choice? Well, humans use data reduction. They actually think about it and they boil it down to one or two things. Often those things they use, consulting firms will call the bases of competition. When I'm choosing between two banks, on what basis do I make that choice? Humans do data reduction. Those are the hoteling beaches that companies compete on. So the goal of machine learning from a strategic point of view is very simple. On what basis do people compare products, for example? Now, the technologies that are applied to this question largely developed in the 1970s and 80s using principal components analysis, factor analysis, multidimensional scaling. All of these tools are used to infer how humans think. Once we can record that, we now have it on a computer. We have an artificial intelligence system that we can use to simulate consumer choices. In essence, discovering the beaches upon which people compare products. Interestingly enough, for example, in pocket calculators, it may be something that you're not expecting because the human mind is rather complex. Turns out there was a period in history when consumers were comparing calculators, and the ones that were considered higher quality were ones that were believed to be more accurate. Now, how is that possible? More accurate? A calculator can't be more accurate, but one company in particular realized that that was a beach that humans were using in their data reduction way. They realized accuracy mattered, so what do? You make the screen a bit larger. You add more decimals. You bevel the buttons so when you push on it, you feel a click, and in particular, you make the calculator heavier. Add a metal plate to the calculator, and people will think it's more accurate. And this is where psychology interacts with machine learning models. The models will understand people's psychology, that's great, but then you have to implement and then position yourself in that space. And so in our next video, what I'm going to do is introduce how we do this data reduction. What are the broad classes of methodologies? Again, the third video will actually give you a demo of how this can be done quick and dirty in a workshop, where you can quickly do some data reduction exercises using multidimensional scaling to actually implement this type of tool. All right, talk to you soon. Bye-bye.